Hello, everybody. Thank you so much for coming. We've got an exciting session for you. I can see most of you are still not quite sleepy. You have not had a heavy lunch. That's good. All right. This is going to be exciting, so stay awake. So the talk is prompt is all you need. For the people who know, it's a take on attention is all you need, the paper that got all this deep learning started out of Google. So what we are going to do is, there's a lot of talk in the industry about all the different tools you need, the specialized models. So, there's a gold rush. Everybody wants to sell you shovels. And there's, a million startups telling you that you need to buy a million things. As we look at it, we are like, this is not a very hard problem. What the hell's going on? Let us show you a really simple way. So, to do something that you can get done after you go back from here, within the next week, build an application within your enterprise that works and that amazes your coworkers, all right? So we're going to talk about how to do that. So I'm not going to talk too much about our product, just 2-3 slides, just so there's enough context for you for the rest of the talk to make sense. So Prophecy is a leader in low-code data pipelines, and low-code is a little different from ETL, and I'll talk about that. And you can do generative AI, Spark streaming, SQL, Airflow. We provide a visual or low-code platform on top of the entire data stack. If you look at modern data stack, we replace everything because they're all features. So just a couple of other slides to talk about some technical parts of the product. So first, Prophecy makes you, this is our bread and butter product. It makes you productive on Spark and SQL. So the typical use cases we are used for is modernizing data engineering. So this is where you have, let's say you're on-prem. If you're an enterprise, you have many legacy products, Informatica, Ab Initio, Data Stage, and a lot of our customers, and they have tens of thousands of pipelines, usually more like 20 to 80 is what we see. And they move their entire footprint onto Prophecy on Databricks. Right, so that's kind of the ETL modernization footprint, and we can auto-import all of that. So that's kind of one business. The second part is for data analysts, we have a data transformation product. So this product, we just actually, we were joking inside the company because there was so much talk of dbt. We are like, what if we built a better product than dbt on dbt core? So what we did is just to show what real engineering looks like. We took the code dbt core, and you can open any dbt core project. And of course, you can edit it, edit the SQL code like you could in dbt. But then the next thing you can do is Prophecy instantly transforms it into visual pipelines. So you can develop these pipelines visually, and so it's round trip. You can go back and forth. And just for fun, we added a data copilot on top. So you can write in English. You can say, hey, give me the top 5 spenders. It's going to take customers, table orders, join them, aggregate them, and develop the pipeline, which converts into dbt. So just saying, if you're thinking of dbt, yeah, you can use dbt core with us, with a real product. All right. Now, the second thing, so actually going back, so the first thing that Prophecy does do is that as you build visual pipelines, we generate very high quality code. So on Spark, this is PySpark or Scala code. This is going to be very clean, very well structured, high performance, going to match your best data engineers. Same happens in SQL, and on the SQL side, it's round trip, because just like I said, you can import any SQL project. Now, and this product actually, sorry, going back again, this product replaces Alteryx's of the world and subsumes the Matillion DBT kind of people. Going back to the next thing, we retain the complete power of code with packages. So what you can do is, it's not only that you can go from visual to code, you can write code, a Spark function, and create a new visual component. So in a sense, all the other vendors are saying, here is a set of visual components. We are saying, here is a visual component builder, and you can build your own packages. So connecting to this talk, generative AI is going to be a package on our core product. And we are going to show you how you can build a package, or we can build a package in a couple of, 3 weeks? Maciek built it in 3 weeks. He wrote all of it. So we have a package that lets you build generative AI apps. So just saying, so that's kind of the background. So that tells you what a low-code, modern ETL product looks like and what it can do. And with that, I'll move to the generative AI part, which is why you're here. So generative AI is changing the world, right? Fastest growing technology, everybody's super excited. And our enterprise customers are, hey, I want to get started, I want to get in on the action. And what's the big problem? The big problem is, on one hand, you have your large language model, like GPT 3.5, the cost-effective one. You can ask it a question about the data it was trained on, but now you've got data in the enterprise, and it knows nothing of your data. You can't say, hey, tell me this thing about my HR policy. Well, your HR policy is lying inside your enterprise, locked down by your IT people. They're doing a good job locking it. But, so now the question is, how do you get past this? So we're going to talk about some myths and talk about the reality of it all. So myths. Generative AI apps require model training or tuning. For the most part, you do not need that. Sometimes you will, but that is an exception. It should be a rare thing. Let's talk about it. So in reality, prompt is all you need. So what does this mean? So the basic thing is, if you were in the previous generation and you were building a fraud model, you would build the model from scratch. But what's great about the generative AI models, they are good general purpose models. So that means that for the most part, they just work, right? So do you need to build your own generative model? Maybe for one use case, 2 use cases in the enterprise, and for that you're going to, spend a lot of money, but you probably have 100 use cases where you could use this. You're not going to be building foundation models for that. What about model specialization, right? So the first thing is, if you have your private data and you look at what is model specialization, it is saying, I am going to embed my private data into the weights of the model. You first have to get a question answer form ready. Then you're going to train the model on that, create a version of GPT 3.5 that is where your data is embedded, and now you're going to say, I'm going to use that. That's one way to go about it. And then, of course, there's the security issues that come with it. How do you create the training set? And the question is, OK, maybe you need it in some cases, but mostly the question is, can you get away by not doing it? So our contention is that prompt engineering is the primary way to go unless you hit limits of it. So for 90% of your use cases, this is going to be just fine. You don't need to do anything else. This is a data problem. So with ever larger prompts, the prompt sizes are increasing, right? We had, I think, Anthropic increased it to 100,000 tokens, which is words. That's huge. You can send full documents on the prompt. I send my text to my blog to ChatGPT all the time, right? I'm like, can you fix my English, being an immigrant and all? And it helps me a lot, right? So the thing is, on the prompt, you can send a lot of data, right? Then just use that. So now, how do we send it relevant private data? Right, that's the problem. We are on the prompt, we want to send it relevant private data. So you create a store for the private data, such as documents, etc., and then you need to look up the private data. So what is the technology for it? It is very simple. I'm just going to spend a minute here. Basically, you can take all your text data, create what is a vector embedding. It's just going to create a vector for it, and store it into a vector database like Pinecone. Okay? You could also store it in Elastic, but people use Pinecone and all. The second thing you can do is, when you get a question, let's say you're building a bot, you can say, for this question, find all the relevant documents that I need. Right? So now you have a way to store these documents. You have a way to look up these documents. So with that technology, let's go back to our problem. Our problem was, how do we create a store for private data and look up the relevant data for the question? You must need 20 new AI tools. No, you don't. If you look at the tools, LangChain has a chain. The chain is, if you look at it as, if you look at an ETL diagram where you have nodes pointing to other nodes, you realize that's a chain. So LangChain has just reinvented ETL. Llama Index has also found ETL again. If you look at Llama Index, it's just ETL. Okay? Of course, there's, just like crypto, there's millions of dollars flowing there, but that's just ETL. You don't need any of this shit. All right. So what you need to do is create a store for your private data. This is very simple. It is classic ETL on unstructured data. So what you have, let's say you're building a support bot. You have support tickets, documents, Slack messages, your product specification, right? And you want to give your support people a support bot. So what you do is you take all of this data, you ETL it into Pinecone or another vector store, right? This is unstructured ETL. If you use Prophecy on Databricks, you can do all of it visually, and Maciek will show you how. And that is your knowledge warehouse. This is parallel to your SQL data warehouse. But just instead of storing tables, it is storing documents. And we talked about how you can use vectors to look it up. The next thing you do is you need to look it up. So this is a streaming pipeline attached to Slack. And Anya in our team, who should be somewhere here, asks a question, answer like a Silicon Valley tech bro, can I install Prophecy on GKE? Right, so when this question comes, it goes to the streaming pipeline. In the pipeline, the question, you convert it into a vector. You look up your knowledge warehouse or vector database, and it says, here are all the relevant documents. You send your question and the relevant documents to GPT and say, give me the answer, and it gives you the answer. Like, that's all you need. You need to be able to send relevant documents with the question to GPT, and it will give you the answer. So you don't need any of this embedding stuff and all that. Myth 3, you require large teams of ML skills. The whole point of large language models is it's a data problem. The model is already there. You don't need a model. You just use ChatGPT. Do you train it? You don't train it. So in summary, you can deploy your first app with one application or data engineer in a week. You develop an ETL pipeline where you take the relevant documents. In the first pass, just put your documentation and put it into Pinecone. You have a knowledge warehouse, okay? Number 2, build a streaming pipeline that gets a question, looks up the relevant documents, asks GPT or LLM, what's the answer given this context, and it'll give you the answer back. Number 3, connect Slack to it. That's it. So it's Slack connected to a streaming pipeline, which is using a data warehouse or a knowledge, let's call it a knowledge warehouse, that you update with an ETL pipeline every day. Like, that's 90% of use cases of generative AI. So with that, just getting, I think, to the demo. I've eaten again into Maciek's time, as okay. I do every time. Sorry. So the summary of myths: you require model training or tuning. You do not. 90% of the cases, prompt is all you need. You need new AI tools. No, you do not. You build a couple of data pipelines in Prophecy. If you want to write code, you can just write it on Databricks. Prophecy with just as a visual layer that makes it easy. Use us or don't use us, that's fine. We can give you an example. And you need large teams, ML scales. No, you don't need that. Couple of people in 1 week, you'll get an app running in your environment. With that, Maciek is going to build it. The marketing team said use 13 minutes. 15 minutes is not cool. So we are using 13. I hope people do not think it's unlucky, because there was a debate, 13 or 14. But Maciek agreed on 13, right?
Yeah, let's do it.
So, all right.
You have the mic already. Yep.
Oh, you have the mic.
OK, awesome. Hey, guys, this is a wonderful crowd. I see some of you have laptops. Everything that I'll be doing, you can actually, thank you, you can actually follow. So what we're going to try to do, and let's all cross fingers, we just have 13 minutes to do that, is we're actually going to build our own chatbot on enterprise data. I come from Prophecy. I'm one of the co-founders here, sitting a little bit more on the technical side. So what I've decided to build is a chatbot that answers directly questions from our support teams, right? It's trained directly on our data. And you have a template available right here. If you're looking down at your laptop, start forking it and building it in Prophecy. Otherwise, of course, you can do it later as well. So let's go ahead. You can start from templates. I'm just actually going to start completely from scratch. This is the Prophecy tool, but everything that we'll be doing is going to be generating high-performance code on Git as well. So let's go ahead, start a brand new project from scratch. This is going to be my Dias generative AI chatbot. Now, I'm a good engineer, so I want to store everything on my GitHub, so I'm just going to connect directly to my Git. I have here a completely empty repository that later on we can actually deploy our code from and just productionize it really simply. So let's go ahead and, oh, sorry, project already exists. I was running this demo many times before the session, so let's go ahead. Perfect. So now we have our project. And so as Raj was saying, there are really two core components to what are we going to be building. One component is the ingestion pipeline. We're actually going to look at some of the data from Asana, Notion, Coda, Slack messages, our documentation, vectorize it, ingest it. And then the other pipeline, the other component is the streaming pipeline itself, right? So read messages directly from Slack, lookup vectors, formulate the answer with OpenAI or whatever model you'd like, and then start sending them out. That sounds like a lot of work. Well, let's get started. So here is my first ingestion pipeline. I'm just going to focus on my web data first, on our open documentation. Perfect. So this is the tool itself. Now, where I'm going to get this documentation from? Well, Prophecy already has public documentation. I have here this sitemap index that contains links to all of my pages. So I can just start directly loading it up. Okay, so what we're going to do is just create the first component that's going to start ingesting the data in. Let me just connect to my Spark cluster. Perfect. Everything is going to be running on Spark natively. And let's just start loading it up. So this is my first source. It's just a web page, nothing fancy. Here's the sitemap. And I can quickly look at the schema under the hood. Everything is being processed as data frames, right? So it doesn't matter how big your documentation is or how many messages you have on Slack. It'll work really, really well. So here should be my sitemap. We just saw the schema. Here's the actual sitemap. Oh, so this actually appears as binary data. No problem at all. We can just very quickly turn it into a string. Everything that we're doing very, very much, I'm sure, reminds you of just standard data processing. Right, so I can just cast this directly to my string. Perfect. And we can actually quickly look at the data. Now, while this is loading, awesome. So we have our actual sitemap. Wonderful. Let's just store it on our DBFS so that we can use it for later. Okay, we can see all of our files right here. So let's just put it here. This is our web indexed. Let's make sure to override this data. And there we go. Now we're actually storing that very first file on our source. Next thing, this is an XML file, right? So I would actually like to start loading this up as an actual XML and processing it link by link and start scraping that data. So we can go ahead and load up the XML source. As you can see, Prophecy has tremendous amount of sources here, right? So it's actually very, very easy for you to just focus on whatever kind of data you're really working with. If I look at that sitemap really quickly, there is those URL fields, right? So I'm going to be fetching all of those URLs stored within those locations. So now we have those locations. Perfect. We can just load them up and start looking at it. And there we go. So this is our every single page. What do we do next? Well, we actually want to start storing all of that wealth of content directly on our data catalog, right? On our Unity catalog. So let's go ahead and start scraping it. Before we do that, there is a bunch of pages that I would actually like to ignore. They all start from this tags page. There is nothing useful there. So I can just very quickly filter out this data. Sorry. Let's filter this data out. Perfect. So any URL that starts with that particular string, we're just going to throw out. OK. And now we're going to be seeing significantly less rows showing up. Awesome. So now we can actually start the process of text scraping. Prophecy features those super useful gems. Normally, you would have to start writing APIs, looking for libraries that you need to use. Here, you just drag and drop and pick the operation that you would like to do. In this case, I would just like to scrape every single one of those URLs. So I can just do directly that. And let's look at the schema on the other side for every single one of those pages. There we go. So now we have our result content. Awesome. Just to speed up the development process itself, instead of working on everything, I'm just going to focus on the first 10 pages just to speed it up. But then we're going to run it on the full data sample as well. So let's scrape just the first 10 pages and look at how that content looks like. Perfect. So now we have our pages. Those pages are actually fairly long. Some of them are over 10,000 characters. They're not going to fit within our model, so we need to split them up a little bit as well. Let's add another text processing gem that's going to split our text into smaller 1,000-character long chunks. Okay, let's look at the schema of it, make sure that that looks good. And perfect, now we have arrays of those chunks. Now, because this is array data, we would like to flatten it. So really quickly, we can do that. Let's flatten that data set while preserving the actual location as well. Okay, so now we have our chunks. Those are just long arrays of text, right? Unstructured data. Let's run this really quick and make sure that now perfect. So now we are having actually more rows showing up, and that's because we've split them up into smaller chunks. Awesome, so what's the next step? Well, now we can actually start vectorizing our data. So I can just drag and drop our OpenAI component here. You can use whatever models you'd like. If you have $100 million on the side, you can train your own model as well, or you can just use something out of the box. So let's go ahead and here use just the standard text embeddings, the ADA model directly from OpenAI. And let's look at the schema. Now we'll be able to start seeing all of those embeddings show up in real time for us. Perfect, we have our OpenAI embeddings. Let's look at how they look like as well. Okay, there we go. Now, for every single one of those documents that we scraped and cleaned up, we start to see the embeddings themselves, right? Perfect. They are 1536 floats long. And now we can start feeding that data directly into Pinecone. Before we do that, I would like to actually start giving it some unique IDs as well. So let's make sure to add our content URL, and let's add an ID as well. So I can just call it, this is going to be focused on my web document, so I can just say, hey, this is web, and then just give it some ID. Okay, perfect. With that, now we can start writing this data out directly to our catalog. So let's just create a brand new table. And this is our data with all the embeddings. So I'm using here Unity catalog. I can just pick my catalog default schema and then just use, I can use one of the tables that already exist. Dice content, perfect. Okay, awesome. So now we have our table that actually contains the content of the posts, the embeddings themselves. I think I forgot the embeddings. The embeddings themselves now will be there as well, and then the actual unique IDs. Now, now we have to start forwarding that data directly to one of our vector databases. There is a couple of them that we can pick. Databricks just announced their own vector search, so you can just start using this, Spark's cosine similarity or Databricks' vector search, no problem at all. But here we're going to use directly Pinecone itself. So I can just drag and drop my embeddings right here as a source and just start writing that data out to Pinecone. Yeah. And sorry, I just overrode that schema accidentally. This is what happens when we're going so fast. Perfect. Connecting to Pinecone and writing to it very efficiently is super easy as well. So we can just say, hey, here's my Pinecone target. Normally, you would have to start calling its APIs and somehow figure out what's the efficient protocol for it from Spark. Here, you can just press, hey, here's my Pinecone connector, set up some credentials, pick what's your index name, and just start writing the data directly to it. So here's your index. And now Pinecone accepts two parameters, right? You need to have unique ID and the embedding itself. The embedding is going to be used as a lookup, and then it's going to just return us similar pages, similar documents to our query, to our embeddings, with those IDs. So then we can start looking up those IDs directly as well. So here's our ID column, and here is our content column. Okay. In the background, while I was talking, I just ran it on the full data sample as well. So we have all the 208 rows writing already to my Delta table, and now I can just run the job directly writing to Pinecone. Okay, that was a lot of work, so we've ingested our web data finally. Lots of data pre-processing, but Prophecy makes it super easy. The other part, now the much more exciting part, is let's start building that live structured streaming pipeline that's actually going to connect to our Slack and start answering questions from our support team. So this is still running. I can just create a new page. Okay, it's actually finished. Perfect. So let's create our live chat. This is going to be a streaming pipeline. Now, what do we start with? I have this channel here directly that I created where I already set up some Slack credentials. It's really easy. All the instructions are out there on the internet. You can follow that as well. And I'm connected to it, so I'll be able to start asking it questions. The very first thing, therefore, that I have to drag and drop onto my canvas is a streaming source that will actually start reading from my Slack directly. So I can just say, hey, here's my Slack source. Let's connect back to my cluster. Sorry about that. Perfect. Okay, so here's my Slack source. I can just connect to the Slack streaming data set, and it's going to essentially start picking up all the messages that are coming from my chat directly. I just have to specify my token. I'm using Databricks secrets here to store all of that securely. And let's look at the schema here. I think we're starting to run out of time really quickly, so I'm just going to do a quick cheat here to load up the schema. Normally, you can just press on infer schema to load it, but just to save some time, this is the schema of the Slack streaming source directly. Okay, perfect. So now what do we have to do? Well, we have to vectorize those questions, look them up on our database, and use OpenAI to start answering questions. A couple of really, really quick and simple steps. First things first, I would like to actually focus on messages from this specific channel, and I would like to make sure that the messages are not overlapping with my chatbot itself, right? So let's make sure that the user itself is not the chat interface. Okay, perfect. Now we can actually start vectorizing some of our queries. So let's just use, again, OpenAI component and vectorize the question itself. I will compute the text embeddings directly on our text column, which represents the question directly from the user. Let's look at the schema, make sure that that looks good. Okay, perfect. Now we have embeddings for our queries. Awesome. Now what we have to do with those embeddings, right? We have to start looking them up on Pinecone directly. So here is a Pinecone lookup component. Again, any vector database will work just fine as well. Let's connect to it. My index, as we've specified before, is this dice all vectors. And I'm going to use the OpenAI embeddings. I expect some really good results coming out of this, so I'm just going to look up a single highest similarity document. And let's look at the schema, and we should start seeing the matches directly coming out of Pinecone itself. Perfect, and so now we'll have those Pinecone matches with IDs to our documents. Okay, what do we do with those? Well, Pinecones will split up a couple of different results for us, so let's make sure that first we flatten that directly into the table. So again, we need our flatten component. And let's get the actual question itself as well. Okay, perfect. Now that we flattened it, we can look up those documents that Pinecone found for us directly on our web embedding source. So I can just drag and drop that source and then drag and drop the join between both of those sources. Prophecy is really smart, so it automatically connects that join for you, and we can just write the join condition itself. So this is going to be our Pinecone ID against the web embeddings ID. Perfect. Okay, there we go. Okay, so now out of this join, we're starting to see the actual documents matched. So the very next thing that we have to do is now start answering some of those questions, right? So here's our embedding, here's the content itself. We can start, sorry about that. Yeah, we can start now using OpenAI to answer our questions. So So I'm just going to drag and drop the OpenAI component. Now we used to do embeddings. Now we have to start doing the actual question answering. And here's the prompt that we are going to use. If you do want to stack up multiple prompts against each other, very easy. If you want to use some agents, some smarter prompts as well, very, very easy to do that as well. And so let's pick our context. Our context is going to be actual content coming out. Let me just double check that. Yes, so that's the actual content, and then the question itself is right here. Awesome. Let's look at the schema, and now OpenAI should start giving us the answers directly on the other side to the question that we are trying to phrase it with the given context. Okay, awesome. So now we have the OpenAI answer. Wonderful. So we're just 2 steps away now from sending that answer back. OpenAI actually gives you multiple suggestions, so let's just pick the very first one. And so we are going to propagate the channel and the timestamp of the message as well. And then let's just choose the answer. OK, with all of that, now the final target that we are dragging and dropping is our Slack target. And so let's open that up. Sorry, just typing really fast. Okay, and this is our channel answer. Yep, that looks good. So yeah, and this is our vectorization component. Okay, we've done it really fast. Let's actually start running it and making sure that I haven't done any mistakes. Crossed fingers that it's going to work the first time. So now I'm running the pipeline itself. I can see the documents already loaded up, and I can start asking my Slack questions, right? Does prophecy support custom UDFs as an example? That's one of the questions that I can ask it. And now I'll be able to also see all of those messages show up on my Spark streaming pipeline in real time, right? So I can see that message show up right here. Here is the event with the full payload. Here is the text of the message. We did some filtering, great. OpenAI vectorized it for us. Here is the actual embedding, perfect. Pinecone found similar matches. Here is the document that matches the closest our question, and here is the score for it. We connected it with our document base. So out of the join, now we can see the actual content of the document, and we can pass it along to OpenAI to actually formulate the answer itself. And here is the answer. And going back to Slack, now I can see that our chatbot actually answered the question for us. Woohoo! Hey. OK, perfect. So this just to give you an idea. This took a little longer than 13 minutes, but we were close. Just to give you an idea of how quickly you can build those generative AI applications directly on top of your enterprise data. And of course, we just here ingested web data, but you can ingest any kind of data. And so with that, there is also really high quality code generated for you. Really encourage you guys to all try it out at home. Or I think now we have some questions to be answered.